Hello everyone, welcome to today's video. In this section, we'll be watching some videos on why your car loses power during acceleration. So, sit back and relax as we begin with 8 ways your car's transmission can cause power loss. Have you ever pressed the gas pedal only to feel your car hesitate or lose power? It could be a transmission issue. In this video, we'll cover 8 ways your transmission can make your car lose power and what you can do about it. But before we continue, hit the subscribe button and turn on the notification bell to be the first to see our video. Let's dive right in. The transmission is responsible for transferring power from the engine to the wheels, and when it develops issues, the car may lose power. Here are 8 ways a faulty transmission can cause power loss. Number 1. Slipping transmission. A slipping transmission occurs when the transmission fails to maintain proper contact between the engine and the wheels, causing a loss of power and inefficient acceleration. This issue can arise in both manual and automatic transmissions and often presents itself through symptoms like high engine RPMs without an increase in speed, difficulty shifting gears, sudden jerking motions, and an overall sluggish driving experience. Number 2. Low or contaminated transmission fluid. A transmission system relies on hydraulic pressure to engage gears and transfer power from the engine to the wheels. Transmission fluid generates this pressure by flowing through various channels and components. If the fluid level drops too low due to leaks, evaporation, or neglect, the transmission cannot build sufficient pressure to shift gears smoothly. Number 3. Torque converter issues. The torque converter plays a crucial role in transferring power from the engine to the transmission. It operates as a fluid coupling device, allowing the engine to spin independently from the transmission when the vehicle is at a stop, then smoothly transferring power when acceleration is needed. When the torque converter starts to fail, power delivery becomes inefficient, leading to sluggish acceleration and high engine revs without a proportional increase in speed. One common issue with the torque converter is a failing stator, which disrupts fluid flow, reducing torque multiplication. Additionally, damaged turbine or impeller blades can hinder the converter's ability to transmit power efficiently. Another common failure is a malfunctioning torque converter clutch, TCC, which should lock up at higher speeds to improve fuel efficiency. If it fails to engage or disengage properly, it can cause excessive slipping, overheating, or a noticeable shudder while driving. Number 4. Faulty Transmission Control Module, TCM. The Transmission Control Module, TCM, manages gear shifts electronically. If it malfunctions, the transmission may get stuck in the wrong gear, causing slow acceleration, hesitation, or failure to shift at all. This results in power loss and poor driving performance. Number 5. Clogged transmission filter. The transmission filter keeps contaminants out of the fluid. Over time, dirt and debris can clog the filter, restricting fluid flow. This can lead to sluggish gear shifts, overheating, and reduced power delivery to the wheels, making the car feel weak during acceleration. Number 6. Worn clutch, manual and automatic transmissions. In a manual transmission, a worn clutch will slip, preventing the proper transfer of power from the engine to the transmission. In automatic transmissions, a failing clutch pack inside the gearbox can cause similar power loss. A slipping clutch will result in high RPMs without an increase in speed, slow acceleration, and a burning smell. Number 7. Delayed or harsh gear shifts. A properly functioning transmission should shift gears smoothly. If there is a delay in shifting, or if the gears engage harshly, power delivery becomes inconsistent. This may be caused by worn-out gears, low fluid levels, or internal damage, leading to reduced performance and slower acceleration. Number 8. Failing valve body. The transmission valve body directs hydraulic fluid to engage the correct gears. If it malfunctions, the transmission may struggle to shift properly, leading to erratic behavior such as gear slipping, staying stuck in one gear, or delayed acceleration. This disrupts power transfer and makes the car feel sluggish. A faulty transmission significantly affects a car's performance, and ignoring these issues can lead to expensive repairs. Regular maintenance, including checking fluid levels, replacing filters, and diagnosing warning signs early, can prevent power loss and ensure smooth driving. If you found this video helpful, hit the like button and subscribe for more car maintenance tips. See you in the next video. In this episode, you'll learn about various car components that can cause a loss of power during acceleration. We'll focus on the timing chain and explore how this crucial engine part can impact your car's performance.
Is your car losing power? Is your fuel economy getting worse? The culprit could be your timing chain. In this video, we'll uncover 10 ways a bad timing chain can destroy your car's performance and what you can do about it. But before we continue, hit the subscribe button and turn on the notification bell to be the first to see our video. Let's dive right in. Number 1, timing chain stretch. Over time, the timing chain can stretch due to wear and tear, especially in high-mileage vehicles or those with poor maintenance. A stretched chain causes delayed valve timing, meaning the intake and exhaust valves open and close at the wrong moments relative to the piston's position. This misalignment disrupts the air-fuel mixture combustion process, making the engine work less efficiently. As a result, the vehicle experiences a noticeable drop in power, sluggish acceleration, and rough idling. Additionally, because the engine is not burning fuel optimally, the car consumes more fuel to compensate for the loss of efficiency, leading to poorer fuel economy and increased emissions. If left unaddressed, a severely stretched chain can cause the engine to misfire or even jump timing, potentially resulting in catastrophic engine failure. Number 2, jump timing. If the timing chain jumps a tooth on the sprocket, the camshaft and crankshaft lose synchronization, causing a severe disruption in the combustion cycle. This misalignment results in delayed or premature valve opening and closing, leading to poor acceleration, sluggish throttle response, and noticeable hesitation. Because the engine's combustion process is no longer optimal, more fuel is burned inefficiently, increasing consumption and lowering fuel economy. In severe cases, the engine may misfire, stall, or refuse to start altogether. And prolonged operation with incorrect timing can lead to costly internal damage, such as bent valves or damaged pistons. Number 3, worn timing chain tensioner. The timing chain tensioner is responsible for keeping the chain tight and properly aligned. A failing or worn tensioner allows excessive slack, leading to erratic timing and inconsistent valve operation. This results in poor combustion, reduced power output, and rough idling as the engine struggles to maintain smooth operation. Additionally, as the tensioner loses effectiveness, the chain may whip or rattle, causing further wear on surrounding components. Poor timing control forces the ECU to adjust fuel delivery incorrectly, making the engine consume more fuel to maintain performance, ultimately leading to reduced fuel efficiency and increased emissions. Number 4, faulty timing chain guides. Timing chain guides help keep the chain in place as it moves between the camshaft and crankshaft sprockets. If the guides wear out, break, or become misaligned, the chain may become unstable, leading to excessive movement or rattling. This instability causes inconsistent valve timing, affecting combustion efficiency, acceleration, and fuel consumption. The engine may experience rough idling, hesitation, and poor power delivery, forcing it to work harder to compensate. Additionally, broken chain guides can result in metal fragments circulating in the engine oil, potentially leading to further internal damage and increased repair costs. Number 5, sludge buildup in the timing system. Poor maintenance and infrequent oil changes can lead to sludge buildup in the engine, restricting oil flow to the timing chain components. Insufficient lubrication increases friction and wear, causing the chain to stretch prematurely and lose precision in valve timing. This leads to delayed combustion cycles, decreased power output, and increased fuel consumption as the engine struggles to maintain efficiency. In severe cases, sludge buildup can clog vital oil passages, causing tensioner failure and leading to catastrophic engine damage. Regular oil changes with high-quality oil help prevent sludge accumulation, ensuring optimal chain performance and improved fuel economy. Number 6, advanced or retarded timing. If the timing chain affects valve timing too much in either direction, too advanced or too retarded, the engine cannot optimize combustion. When timing is too advanced, fuel ignites too early, causing knocking, overheating, and inefficient fuel use. When timing is too retarded, the combustion cycle lags, leading to sluggish acceleration, poor throttle response, and an increase in unburnt fuel emissions. These timing irregularities force the ECU to compensate by adjusting fuel injection, which leads to excess fuel consumption and reduced power output. Long-term effects include premature wear on engine components and increased carbon buildup inside the combustion chamber. Number 7. Timing chain noise and friction loss. A worn-out or loose timing chain may produce rattling or clattering noises, especially during startup or acceleration. This excessive play causes additional friction, which absorbs engine power and reduces efficiency. As a result, the engine may experience slower throttle response, reduced fuel economy, and higher operational temperatures due to increased mechanical resistance. The ECU may attempt to compensate for power loss by increasing fuel injection, further worsening fuel consumption. If ignored, excessive timing chain movement can lead to severe wear on the sprockets and guides, increasing the risk of complete chain failure. Number 8. Damaged or misaligned camshaft sprockets. If the camshaft sprockets become worn, misaligned, or damaged, they can no longer maintain proper chain tension. This results in irregular timing, inconsistent combustion, and a noticeable reduction in power output. The misalignment forces the engine to work harder to compensate for inefficient fuel-air mixture burning, leading to increased fuel consumption and emissions. Over time, a damaged sprocket can accelerate timing chain wear, eventually causing severe mechanical failure if left unaddressed. Regular inspections and timely replacements help prevent costly repairs and maintain engine efficiency. Number 9. Inconsistent valve operation. A faulty timing chain can result in the intake and exhaust valves opening and closing at the wrong time, disrupting airflow into and out of the engine. This leads to poor air intake, incomplete fuel combustion, and overall power loss, making the engine less responsive and less efficient. Because fuel is not being burned optimally, excess unburnt fuel is wasted, causing increased fuel consumption and emissions. Additionally, inconsistent valve operation can cause misfires and rough idling, making the engine run less smoothly. Over time, these issues can contribute to carbon buildup, overheating, and premature engine wear. Number 10. Check engine light and limp mode activation. Modern vehicles are equipped with sensors that monitor the timing system. If the ECU detects a timing chain issue, it may trigger error codes and activate limp mode as a protective measure. Limp mode reduces engine power output to prevent further damage, causing poor acceleration and fuel inefficiency. Additionally, the ECU may enrich the air-fuel mixture to stabilize the engine, leading to higher fuel consumption and emissions. In severe cases, the engine may shut down entirely or fail to start. A diagnostic scan can reveal timing-related trouble codes, allowing for timely repairs before further damage occurs. A bad timing chain can kill your car's power and fuel economy. If you notice any of these symptoms, get your timing chain inspected immediately. If you found this video helpful, give it a thumbs up, subscribe for more car tips, and share with fellow car owners. See you in the next video.
Let's examine how a clogged fuel filter can cause your car to lose power during acceleration. What is a fuel filter? A fuel filter is an essential component in an internal combustion engine's fuel system. Its primary role is to ensure that the fuel entering the engine is free from contaminants. Now, let's understand the 5 key functions of a fuel filter. Number 1. Removal of contaminants. The primary function of a fuel filter is to remove contaminants such as dirt, rust, and other particulate matter from the fuel. These contaminants can originate from the fuel tank, during refueling, or from deteriorating components within the fuel system. By filtering out these impurities, the fuel filter helps prevent damage to the fuel injectors and engine. Number 2. Protection of fuel system components. The fuel filter plays a crucial role in protecting various components of the fuel system, including the fuel pump and fuel injectors. Contaminants in the fuel can cause abrasion and wear, leading to premature failure of these components. A clean fuel system ensures optimal performance and longevity of the engine. Number 3. Ensuring optimal engine performance. By providing clean fuel to the engine, the fuel filter helps maintain optimal combustion efficiency. Contaminated fuel can disrupt the fuel-air mixture, leading to poor combustion, reduced power output, and increased fuel consumption. A clean fuel filter ensures that the engine runs smoothly and efficiently. Number 4. Enhancing fuel efficiency. A properly functioning fuel filter contributes to better fuel efficiency. When the fuel is free of impurities, the engine can burn it more efficiently, resulting in improved fuel economy. Conversely, a clogged or dirty fuel filter can restrict fuel flow, causing the engine to work harder and consume more fuel. Number 5. Reducing emissions. Clean fuel helps the engine run more efficiently, which in turn reduces harmful emissions. A well-maintained fuel filter ensures that the engine operates within its optimal parameters, producing fewer pollutants. This is particularly important for meeting environmental regulations and standards aimed at reducing air pollution. In summary, the fuel filter's functions of removing contaminants, protecting fuel system components, ensuring optimal engine performance, enhancing fuel efficiency, and reducing emissions are crucial for the overall health and efficiency of an internal combustion engine. Regular maintenance and timely replacement of the fuel filter are essential to keep the fuel system clean and the engine running smoothly. Now, let's look at how a bad fuel filter can cause your car to lose power. A bad fuel filter can significantly impact a car's performance and cause it to lose power. Here are 5 ways in which a clogged or failing fuel filter can lead to a power loss. Number 1. Restricted fuel flow. A clogged fuel filter restricts the flow of fuel to the engine. This limitation means the engine isn't receiving the adequate amount of fuel it needs for proper combustion. As a result, the engine may struggle to generate power, particularly under load or during acceleration. This can lead to sluggish performance and difficulty maintaining speed. Number 2. Lean fuel mixture. When a fuel filter is partially blocked, it can cause an uneven or lean fuel mixture, too much air and not enough fuel. A lean mixture can result in poor engine performance, including misfires, stalling, and reduced power output. The engine control unit, ECU, may struggle to compensate for the inadequate fuel supply, further exacerbating power loss. Number 3. Engine misfires. Contaminants that bypass a faulty fuel filter can reach the fuel injectors and cause them to become clogged or malfunction. Dirty or damaged fuel injectors can lead to incomplete combustion and engine misfires. Misfires not only reduce engine power but can also cause rough idling, poor acceleration, and increased emissions. Number 4. Increased engine stress. A bad fuel filter forces the fuel pump to work harder to push fuel through the blockage. Over time, this added stress can cause the fuel pump to wear out or fail prematurely. A failing fuel pump can lead to inconsistent fuel pressure, causing the engine to lose power and potentially stalling altogether. Number 5. Reduced fuel efficiency. When the fuel filter is clogged, the engine has to work harder to maintain performance. This increased effort can lead to higher fuel consumption as the engine compensates for the restricted fuel flow. Reduced fuel efficiency is often a sign of a struggling fuel system and can indicate an underlying issue with the fuel filter. In summary, a bad fuel filter can cause a car to lose power by restricting fuel flow, creating a lean fuel mixture, causing engine misfires, increasing engine stress, and reducing fuel efficiency. Regular maintenance and timely replacement of the fuel filter are essential to prevent these issues and ensure optimal engine performance. Regular maintenance and timely replacement of your fuel filter are crucial for keeping your engine running smoothly and efficiently. Thanks for watching. If you found this video helpful, please like, share, and subscribe to our channel for more automotive tips and insights. The next car component that can cause a loss of power is the mass airflow, MAF, sensor. What is a mass airflow, MAF, sensor? The mass airflow sensor, commonly called the MAF sensor, is crucial to your vehicle's engine management system. Its primary role is to measure the amount of air entering the engine. This data is vital for the engine control unit, or ECU, to balance and deliver the correct fuel mixture to the engine. Now, let's look at the 5 key functions of a mass airflow sensor. Number 1. Measuring air intake. The primary function of the MAF sensor is to measure the volume and density of air entering the engine. This measurement is crucial because the air entering the engine directly affects the combustion process. The sensor typically measures this by using a heated wire or film. As air flows over the wire, it cools down, and the sensor calculates the air flow rate based on how much current is needed to maintain the wire's temperature. Accurate air measurement ensures the engine receives the correct air for optimal combustion. Number 2. Ensuring optimal air-fuel ratio. The air-fuel ratio is the air-to-fuel ratio in the combustion mixture. This ratio must be kept within a certain range for efficient combustion and engine performance. The MAF sensor provides real-time data on the air entering the engine, allowing the Engine Control Unit (ECU) to adjust the fuel injection accordingly. This precise control helps maintain the optimal air-fuel ratio, ensuring complete combustion, maximizing power output, and minimizing fuel consumption. Number 3. Supporting emission control. Modern engines are designed to meet stringent emission standards. The MAF sensor plays a critical role by helping the ECU maintain the correct air-fuel mixture, which is essential for reducing emissions. Proper combustion minimizes the production of harmful pollutants such as carbon monoxide, hydrocarbons, and nitrogen oxides. By ensuring efficient combustion, the MAF sensor helps the catalytic converter function effectively, reducing the vehicle's environmental impact. Number 4. Enhancing fuel efficiency. Fuel efficiency is a significant concern for vehicle owners. The MAF sensor improves fuel economy by providing accurate airflow data, allowing the ECU to optimize fuel injection. The engine can burn fuel more efficiently when the air-fuel mixture is correctly balanced. This not only improves mileage but also reduces fuel costs. Additionally, efficient fuel use reduces the strain on the engine, potentially extending its lifespan. Number 5. Improving engine performance. The overall performance of the engine depends on the precise coordination of various components, with the MAF sensor being a key player. By accurately measuring air intake, the MAF sensor ensures that the engine receives the right amount of air, which is essential for smooth and consistent power delivery. This results in better throttle response, smoother acceleration, and overall improved drivability. A well-functioning MAF sensor helps the engine run at its best, providing a more enjoyable and reliable driving experience. In summary, the MAF sensor is vital for measuring air intake, ensuring the optimal air-fuel ratio, supporting emission control, enhancing fuel efficiency, and improving engine performance. Its accurate data helps the ECU manage the engine effectively, leading to better fuel economy, reduced emissions, and a smoother, more powerful driving experience. Ways a faulty MAF sensor can cause power loss. While the MAF sensor plays a vital role, a malfunctioning one can lead to significant issues, including loss of power. Here are 5 ways a faulty MAF sensor can cause your car to lose power. Issue 1. Incorrect air-fuel mixture. A faulty MAF sensor can send incorrect data about the amount of air entering the engine to the Engine Control Unit, ECU. The ECU relies on this data to adjust the fuel injection to achieve the proper air-fuel mixture. If the MAF sensor reports inaccurate readings, the ECU may inject too much or too little fuel. This can lead to a rich mixture, too much fuel, or a lean mixture, too little fuel, both of which can cause the engine to run inefficiently and lose power. Issue 2. Engine misfires. An improper air-fuel mixture resulting from a faulty MAF sensor can cause engine misfires. Misfires occur when the fuel in one or more of the engine cylinders fails to ignite properly. This can lead to a rough-running engine, reduced power, and increased emissions. Misfires can also cause damage to other engine components over time, leading to further performance issues. Issue 3. Poor acceleration. When the MAF sensor is not functioning correctly, the ECU may struggle to provide the right amount of fuel during acceleration. This can cause the engine to hesitate or stumble when you try to speed up, leading to poor acceleration performance. You might notice a lag or delay when pressing the accelerator pedal, making it difficult to achieve smooth and responsive acceleration. Issue 4. Rough idling. A malfunctioning MAF sensor can lead to rough idling or even stalling when the car is at a stop. This happens because the ECU cannot maintain a stable air-fuel ratio at low engine speeds without accurate airflow data. Rough idling can make the engine feel unstable, with noticeable vibrations and fluctuations in RPMs. In severe cases, the engine may stall completely when idling. Issue 5. Increased fuel consumption. To compensate for inaccurate airflow data from a faulty MAF sensor, the ECU might overcompensate by injecting more fuel than necessary. This results in higher fuel consumption, as the engine burns more fuel to try to maintain performance. Increased fuel consumption not only reduces fuel efficiency and increases operating costs, but also contributes to a decrease in engine power because the engine is not running optimally. In summary, a faulty MAF sensor can lead to incorrect air-fuel mixtures, engine misfires, poor acceleration, rough idling, and increased fuel consumption. These issues can collectively cause significant power loss in a car engine, affecting overall performance, fuel efficiency, and drivability. Regular maintenance and timely replacement of a faulty MAF sensor can help prevent these problems and ensure your engine runs smoothly. Regular maintenance is key. Regular maintenance and timely replacement of a faulty MAF sensor can prevent these issues and keep your engine running smoothly. If you suspect your MAF sensor is failing, it's best to have it checked by a professional mechanic. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more automotive tips and insights.
Hello everyone. In today's video, we are going to talk about the top cause of why your car engine is losing power when accelerating. We will look into fuel system issues, ignition system problems, air intake restrictions, exhaust system obstructions, and engine mechanical issues. But before we continue, please hit the subscription button and turn on the notification bell so that you will be the first to see my video once it drops. Let us begin. Loss of power when accelerating can be caused by various factors, and diagnosing the exact issue may require professional inspection. However, some common causes of this problem include fuel system issues. Fuel system issues can significantly impact engine performance and lead to loss of power during acceleration. Here are 5 ways fuel system problems can cause this issue. Number 1. Fuel filter clogging. A clogged fuel filter restricts the flow of fuel to the engine, limiting the amount of fuel available for combustion. This restriction can result in inadequate fuel delivery to the cylinders during acceleration, leading to a loss of power. Number 2. Dirty or faulty fuel injectors. Dirty or malfunctioning fuel injectors may spray fuel unevenly or inconsistently into the combustion chambers. This uneven fuel distribution can cause misfires or incomplete combustion, resulting in a decrease in engine power, especially under acceleration. Number 3. Low fuel pressure. A failing fuel pump or fuel pressure regulator can lead to low fuel pressure in the fuel system. Insufficient fuel pressure reduces the amount of fuel delivered to the engine, particularly during high-demand situations like acceleration, leading to a loss of power. Number 4. Fuel contamination. Contaminants such as water, dirt, or debris in the fuel system can disrupt fuel flow and combustion. These contaminants may clog fuel lines, injectors, or the fuel filter, causing irregular fuel delivery and decreased engine performance, including reduced power output during acceleration. Number 5. Fuel system leaks. Leaks in the fuel system, such as from damaged fuel lines, connectors, or seals, can lead to a drop in fuel pressure and fuel volume reaching the engine. Reduced fuel supply to the engine under acceleration can result in insufficient fuel-air mixture, leading to hesitation and loss of power. Addressing fuel system issues promptly through regular maintenance, such as fuel filter replacement, injector cleaning, and fuel system inspections, can help prevent power loss during acceleration and ensure optimal engine performance. If you experience persistent power loss issues, it's essential to consult with a qualified mechanic for a thorough diagnosis and repair of the fuel system problem. Ignition system problems. Ignition system problems can significantly impact engine performance and lead to a loss of power during acceleration. Here are 5 ways ignition system issues can cause this problem. Number 1. Weak or inconsistent spark. Worn or fouled spark plugs or malfunctioning ignition coils can result in a weak or inconsistent spark. This inadequate ignition spark leads to incomplete combustion in the cylinders, reducing engine power output during acceleration. Number 2, misfires. Ignition system problems such as faulty spark plugs, ignition coils, or ignition timing can lead to misfires. Misfires occur when the air-fuel mixture fails to ignite properly in the combustion chamber, resulting in a loss of power and hesitation during acceleration. Number 3, timing issues. Incorrect ignition timing, whether too advanced or too retarded, can affect engine performance. Timing issues can cause inefficient combustion, leading to a decrease in power output during acceleration and overall engine performance. Number 4, faulty ignition components. Components of the ignition system, such as the distributor cap, rotor, or ignition wires, may become worn or damaged over time. Faulty ignition components can disrupt the distribution of electrical energy to the spark plugs, resulting in irregular engine firing and power loss under acceleration. Number 5, electronic ignition system. Malfunctions. Modern vehicles equipped with electronic ignition systems rely on various sensors and control modules to manage ignition timing and spark delivery. Malfunctions in these components, such as a faulty crankshaft position sensor or ignition control module, can disrupt the ignition process and lead to a loss of power during acceleration. Dealing with ignition system issues promptly by adhering to routine maintenance practices like replacing spark plugs, inspecting the ignition system, and conducting diagnostic tests can prevent power loss during acceleration and maintain peak engine performance. If you encounter persistent power loss problems, it's crucial to seek assistance from a skilled mechanic for a comprehensive diagnosis and resolution of the ignition system issue. The next issue that will make your car engine in losing power when accelerating is air intake restrictions. Air intake restrictions can significantly affect engine performance and lead to a loss of power during acceleration. Here are 5 ways air intake restrictions can cause this problem. Number 1, clogged air filter. A clogged or dirty air filter restricts the flow of air into the engine, reducing the amount of oxygen available for combustion. This restriction leads to an imbalance in the air-fuel mixture, resulting in decreased engine power output during acceleration. Number 2, blocked mass airflow sensor, MAF. The mass airflow sensor, MAF, measures the amount of air entering the engine to ensure proper fuel delivery. If the MAF sensor becomes blocked or dirty, it may provide incorrect readings to the engine control unit, ECU, leading to fuel delivery issues and a loss of power during acceleration. Number 3, restrictive air intake system. Some aftermarket or performance air intake systems may be designed with restrictive components that hinder airflow to the engine. This restriction can limit the amount of air available for combustion, reducing engine power output under acceleration. Number 4, leaking intake manifold gasket. A leaking intake manifold gasket can introduce unwanted air leaks into the intake system, disrupting the air-fuel mixture. This can lead to erratic engine performance and a loss of power, particularly during acceleration. Number 5, blocked throttle body. The throttle body regulates the amount of air entering the engine. If the throttle body becomes blocked by carbon deposits or debris, it can restrict airflow to the engine, reducing power output during acceleration. Addressing air intake restrictions promptly through regular maintenance, such as air filter replacement, MOF sensor cleaning, and throttle body cleaning, can help prevent power loss during acceleration and ensure optimal engine performance. If you experience persistent power loss issues, it's essential to consult with a qualified mechanic for a thorough diagnosis and repair of the air intake restriction problem. The next issue that will make your car engine lose power when accelerating is exhaust system obstructions. Exhaust system obstructions can significantly impede engine performance and result in a loss of power during acceleration. Here are 5 ways exhaust system obstructions can cause this issue. Number 1, blocked catalytic converter. A blocked or clogged catalytic converter restricts the flow of exhaust gases out of the engine. This restriction creates back pressure in the exhaust system, inhibiting the engine's ability to expel exhaust gases efficiently. As a result, engine power output is reduced during acceleration. Number 2, exhaust manifold leaks. Leaks in the exhaust manifold can allow exhaust gases to escape before reaching the catalytic converter. This loss of pressure can disrupt the scavenging effect in the exhaust system, reducing engine efficiency and power output, particularly during acceleration. Number 3, collapsed or restricted exhaust pipe. A collapsed or restricted exhaust pipe limits the flow of exhaust gases from the engine. This restriction creates a bottleneck in the exhaust system, increasing back pressure and reducing engine power output, especially under high load conditions such as acceleration. Number 4, blocked or restricted muffler. A blocked or restricted muffler impedes the flow of exhaust gases and dampens noise. If the muffler becomes clogged with debris or internal components deteriorate, it can disrupt exhaust flow and reduce engine power output during acceleration. Number 5, exhaust gas recirculation, EGR system issues. Malfunctions in the exhaust gas recirculation, EGR system, such as a stuck EGR valve or clogged EGR passages, can affect engine performance. A dysfunctional EGR system may cause exhaust gases to recirculate excessively, leading to reduced engine power output and acceleration performance. Addressing exhaust system obstructions promptly through regular maintenance, such as catalytic converter inspection, exhaust manifold repair, and muffler replacement, can help prevent power loss during acceleration and ensure optimal engine performance. If you experience persistent power loss issues, it's essential to consult with a qualified mechanic for a thorough diagnosis and repair of the exhaust system obstruction problem. The next issue that will make your car engine lose power when accelerating is engine mechanical issues. Engine mechanical issues can significantly impact engine performance and lead to a loss of power during acceleration. Here are 5 ways engine mechanical issues can cause this problem. Number 1, low compression. Worn piston rings, damaged cylinder walls, or leaky valves can result in low compression in the cylinders. Low compression reduces the engine's ability to generate power, particularly during acceleration, leading to a loss of power. Number 2, overheating. Engine overheating can cause damage to internal components such as pistons, valves, and cylinder heads. This damage can result in decreased engine efficiency and power output, especially during periods of high demand like acceleration. Number 3, timing belt chain issues. A worn or stretched timing belt or chain can cause timing discrepancies between the engine's components, leading to inefficient combustion and reduced power output during acceleration. Number 4, valve train problems. Bent or damaged valves, worn valve guides, or stuck valve lifters can affect the engine's ability to intake air and fuel and expel exhaust gases. This can result in incomplete combustion and decreased power output, particularly during acceleration. Number 5, internal engine wear. Wear and tear on internal engine components such as pistons, piston rings, connecting rod bearings, and crankshaft bearings can reduce engine efficiency and power output. This wear can lead to increased friction and decreased compression, resulting in a loss of power during acceleration. Addressing engine mechanical issues promptly through regular maintenance, such as checking and replacing worn components, performing routine inspections, and monitoring engine temperature, can help prevent power loss during acceleration and ensure optimal engine performance. If you experience persistent power loss issues, it's essential to consult with a qualified mechanic for a thorough diagnosis and repair of the engine's mechanical problem. So if you like this video and you want to see more car maintenance tips, hit the subscription button and turn on the notification bell so that you won't miss out on our car maintenance tips. Thank you.